Hello everyone, in this video we'll be talking about the RMS power of AM wave. As we already know, AM wave has a carrier signal plus two side bands. So the RMS power of the carrier signal is equal to PC is equal to VC square by 2R. Here VC is the amplitude of the carrier voltage and R is the resistive part of the load impedance, and usually which is antenna. Now the power in the lower sideband is equal to mu square by 4 PC, as well as the power in the upper sideband is also mu square by 4 PC. Got it? So the total power in the two sidebands is equal to mu square by 2 PC. If we want the total RMS power of the AM wave, it will be equal to PC plus P LSB plus P USB, means the power of the carrier wave plus the power of lower sideband plus the power of the upper sideband, which gives us the expression P total is equal to PC multiplied with 1 plus mu square by 2. Got it? If we want to obtain the fraction of the power contained in the sidebands, then we should divide the total power of two sidebands by the PT, the total power. Got it? It will give you the expression mu square by 2 plus mu square, which is an important expression. It gives you the idea that power contained in the sidebands depend upon the modulation index. Suppose we take mu is equal to 0, the modulation index is 0. How much is the power in the sidebands? 0. Suppose we take mu is equal to half, then the power contained in the sidebands is 1 by 9 of the total power, which is equal to 11.1% of the total power. And suppose we take the best possible case, mu is equal to 100% modulated wave. In this case, the power contained in the sidebands is equal to 1/3 of the total power, means 33.3% power is lying in the sidebands and more than 66% power is vested in the carrier. This is the disadvantage of the AM signal. A majority part of the power is contained in the carrier, and carrier carries no useful information, no audio signal, no video signal, no data. Got it? The message signal is contained in the sidebands. So for better reception of the signal, the power in the sidebands should be as much as possible. Is it okay? And we can take two good questions to understand this thing. So let's start with the question. Here you can see the first question on the board. If you wish, you may give it a try and then I'll be simplifying it. I hope you got the answer, as the power in lower sideband is 250 watt, power in the upper sideband is 250 watt, the power in two sidebands is 500 watt, and the total power of the AM signal is 1500 watt. Let us see the calculation. The solution is pretty simple. We are given the power of the carrier is equal to 1000 watt. Do you agree? And we need the power in the lower sideband. We know the formula. Power in the lower sideband is mu square by 4 PC. Modulation index mu is given as 1. So it will be equal to 1 square by 4 into 1000 watt, which is equal to 250 watt. Is it okay? The power in the upper sideband will also be same. Then if you need the total power PT, these all are the RMS powers. Okay, PT will be equal to PC plus P LSB plus P USB. So putting up the data in this formula, answer is pretty simple. PC is given as 1000 watt, P LSB was 250 watt, and P USB was also 250 watt. So the total answer comes out to be 1500 watt. Is it okay? And here is another nice information. If you check the total power in two side bands, which is equal to 500 watt, and that 500 watt is exactly half of the 1000 watt. Whenever we have mu is equal to 1, means 100% modulation, then the total power in two side bands will always be half of the carrier power. You may note it down, then we'll be taking up the second question. Here is the second question on the same track as the previous question number 1. So if you wish, you may pause here and you can give it a try. I am simplifying the things on the board. We are given that mu is 0.7, means 70% modulation, and the power in the carrier signal is 250 watt. So the power in the lower side band or the power in the upper side band we know is equal to mu square by 4 PC. Do you agree? Computation is simple. 0.7 whole square divided by 4 into 250 watt. When you do the calculation, it will come out to be 30.625 watt. Is it okay? Now, suppose we want to calculate the total power of the signal. These all are the RMS powers. So, P total will be equal to PC plus PLSB plus PUSB. It's a formula. We'll be putting up the values in the formula and we'll get the total RMS power. PC is 250 watt. PLSB is 30.625 watt. PUSB is also same 30.625 watt. Doing the calculation, the total RMS power comes out to be 311.25 watt. Got it? So it's a simple question. You may note it down and then we'll be taking up one conceptual question. After that, you'll get a checkpoint. Here is the last question of this video. It's a simple conceptual question. If you wish, you may post your answer in comment box. I am giving the answer on the board. In an AM wave, we know there is a carrier, okay, there is a lower side band and there is an upper side band. Do you agree? This carrier carries no information, no audio signal, no video signal, no data. So we should not send it. To maximize the power efficiency, we should send the lower side band or the upper side band or both. Actually, these two contains the message. Got it? Now you'll be getting a checkpoint and later on its answer. I hope you enjoyed the video. Stay awesome. See you again.